So you take the square root of both sides. So the square root undoes
Yeah.
it. So if it's x squared, it becomes x. If you have the square root of x and you square it, you also get x. So it undoes each other. Can you tell me the square root of 25, please? Again, you're welcome to use that calculator. Okay. So this is your first what's called a Pythagorean triple. And the name isn't important, but what is important is remembering that they're all integers. 3, 4, and 5 are all integers. Okay, and it's kind of a rare occurrence. Usually they're not, but for some of them they are. Okay, and they're not. This is the only one where they're one off from each other. Okay, so let's look at another one here. All right, what can you tell me the Pythagorean theorem?
A squared plus B squared equals C squared.
Very good. A and B are the legs, C is the hypotenuse. Can you give me the values of A and B, please?
Yeah. 289.
So just to be clear here, I was just looking for A and B. It sounds like you went to the calculator already, which is great. Okay. If you're going to go to the calculator, why don't you finish it off here? What is the value of C? Sorry, what is the square root of 289? How do you undo that?
Same.
Do you have an answer for me?
Not really.
Square root of 289. You got to go to that calculator and calculate that just like you did in the last. Unless you already knew the value, maybe that's why you didn't do it. But you have to enter square root 289.
Okay. Six.
Nope, try again. Square root symbol and then the 289 right underneath.
Uh, 17.
Yes. Yes. Okay. So do you understand the flow here? You get two of the three sides. If it's the legs, that's A and B. You square them, square each one, add them together, and then take the square root.
Yeah.
Okay. Fantastic. Because we're gonna do a bunch more. So I don't want you to say, I don't know how to do this or be unsure. I want you to say, okay, yeah, I think I can do this. So here is another one for you to look at. So just a little different setup here. They're giving you the triangle. Okay. And they're giving you the values of A and B, and they want you to solve for C.
Third. 13.
Yep. Excellent. Okay, let me give you a slightly more difficult one here, meaning just the numbers are going to get a little bigger. I'm just sort of scrambling here, trying to get this to get one here maybe you haven't seen. Yeah, here's another one. Right. Okay, one more here. If you want to solve, actually, let me go up here and write that C is 13 in case you want to look back at this later. All right, go ahead and look at this one, please, and solve for that.
Um, 10.
C is 10. Very good. Okay, so here's a new style of problem. We'll work out a couple together here. So here's another right triangle, just like the last few that we've been given. Let's say I tell you that this is 9 and this is 15, and I want you to solve for B. Okay, so the difference now is that I'm giving you the hypotenuse. I'm giving you C. And sometimes it's a good idea to actually label it like, okay, that's A, that's B, and that's C. So that when you write the formula A squared plus B squared equals C squared, you say to yourself, okay, what am I given? And you're given a leg, 9. You don't know B, but you do know C. Okay, so this time you can't just add them together because the 15 squared is on the right side of the equation. You see that this is different than the previous ones we've been doing?
Yeah.
Okay, I heard a little hesitation there. So just if it's not clear, just say so. But this time when you square 9, you get 81. When you square 15, it's 225. You can't just add them together. In fact, you have to do something different. You have to move this 81 to the other side of the equation. How do you do that?
Move what?
How do you
80.
move? Yeah, how do you move this 81 to the other side of the equation?
Oh, the subtract.
Subtract. You're going to subtract 81. Okay, so now B squared equals, can you go to your calculator and get me that result?
144.
144. Fantastic. Now, what is the last step here to solve for B?
Square it. Yeah, wait. Square root.
Yes, square root of both sides. Can you give me that result, please?
Yeah, 12.
It is 12. Very good. All right, let's do one more together, and then I'll give you a couple to try on your own. All right, here we go. So it says if A equals 9, B equals, well, we're not sure, and C equals 41, solve for B. Okay. So notice that you can draw the right triangle a bunch of different ways. Okay. But you have to recognize that A and B are still the legs. All right. So even though they're giving you a different orientation, it's still solved the same way. This is 9, this is unknown, and this is 41. And it's a good idea to throw the numbers in. If you remember from geometry, it's good to kind of label, draw things out. That's usually very helpful. Is that clear?
Yeah.
Okay. So now again, we're using A squared plus B squared equals C squared. Can you tell me the values that were given in the problem here?
Yeah, 9 and 41.
And is 9 A or B?
A.
It's A. So you'd write 9 squared. Do you know B?
No.
B is the thing we're trying to find. And then C is 41. So I want you to go to your calculator here and tell me what 9 squared is, and then tell me what 41 squared is, please.
Um, 81 and 1,681.
1,681.
Yeah.
Why doesn't that look right to me? Just me, that's off. Okay.
Or
No, you were
yeah,
correct. You were correct. It looked strange to my eye. I don't know. I guess I was expecting a different number. You know,
that's
whatever.
what I thought too. Man.
It is correct. So sorry for questioning you. What's the next step here to solve for B? How do we undo this 81?
No, subtract 81,
Okay.
1600.
Okay. And what do you do
And
from
then
here to
square root 1600,
good?
and I guess you'll get 40.
Are you surprised that worked out nicely?
A little bit, I guess. Yeah.
Okay. All right. Yeah. It does work out nicely. Okay. Do you have this down in your notes? Do you need some time to write it down? I do want to give you one or two to try, if you don't mind.
Yeah.
Let me know when you're ready for one to try.
All right. Yeah, I'm ready.
Okay. Clear the screen here. 1, 2, 3, go. If you have questions, please ask, but this is not that different than the ones we've been doing.
Uh, 12.
Yes. That was pretty fast. That was actually faster than when we do it together. What's the difference?
And I don't know. Isn't
No,
really
it's
much.
good. It's good. I'm just asking, like, is there something different? Because I mean, I can't see what you're doing, but I mean, that's fantastic. Here you go. Here's another one to look at. How are you doing on this one?
Good.
Do you have an answer for me? Do you have questions?
Uh, $514.
It can't be
Yeah.
that much different than these. And it is almost identical to this. It's just different numbers. So like whatever you did here worked, but whatever you did here did not work. So I was just going back and looking at what you did on this one, or even going back to the ones that we just did. The only difference is the numbers.
Did 8?
It is 8. What was the mistake that you made the first time?
I know. I think it just had to do with me, like. I think I just made a calculation there, to be honest. I don't know how
I mean,
got that unfortunate.
here's what I believe you did. I think you took 15, squared it, 17 and squared it and add them together. Why is that wrong?
Well, you don't. I mean, C or B isn't 17.
B is not 17. And here's what I don't want you to hear, Tristan. I don't want you to hear me saying that you're wrong. I'm asking you what is wrong about this calculation. And you said it correctly. You said, well, B is not 17. It's actually C. Do we know B?
No.
That's what we're trying to find. Now, how did you come up with 8 from here? What did you do next?
Oh,
What did we do from 9 squared to this next line?
you just scored it.
Okay, so what do you think you should do here?
Well, score it.
Squared. What's 15 squared?
Pretty sure I did that before, but 225.
Good. What is 17 squared?
289.
Okay. What's the next step here to solve for B?
Square it.
We can only do that when B is by itself. See how B is
Oh
solo?
yeah, subtract it. I'm sorry.
Yeah. And again, I'm not trying to be, difficult with you. I'm just trying to get you to tell me verbally. That's just a learning thing, where if you explain the steps to me, maybe you will retain them better. We'll see. What is the subtraction of this? Does that become?
Should be 64,
Yes.
and then square it down, you get 8.
Yes. Very good. All right. Awesome. Quick question for you. Just curious. Have you ever played video games? Do you like video games?
Yeah.
So there used to be a bunch of games that I would play as a kid, and sometimes I would like pass the level or beat the boss, and I had no idea how I did it. You just sort of like, tried a bunch of stuff. And the next time you played the game, you had to get to the same place. You're like, what happened? That is why I'm trying to step you through this. Have you step me through it so you can tell me, like, imagine a friend came up to you in class, say, hey, how do we do this? You would tell them, okay, well, you got to do this and this and this and this. And it will show your understanding of it. That's why I'm asking you to do it, because I think that could help you retain some of this information.
Yeah.
So here's a new problem for us to look at together. And let's see here. This is 2, this is 4, and this is C. We have a squared plus b squared equals c squared. What's the value of a in this problem?
4.
Okay, what if I said, no, a has to be 2? Is that okay?
Sure.
So the reason is a and b can kind of alternate. It doesn't really matter which one's a or b, as long as they're both the legs. Okay, but we'll go with 4 and 2. 4 squared is 16, 2 squared is 4, 16 plus 4 is 20. Could you go to your calculator and calculate the square root of 20 for us, please?
2.
Square root of 20?
4.47 or 4.4.
So what I heard, and this is I hope what you're using is the thing I sent over, that Decimal Scientific. This is what you got for C, is that right?
Yeah.
This is wrong. Okay. You're like, why is it wrong? The calculator said it's that number. So in this course, you have to do what's called reduce roots. Okay. They want an exact answer. And an exact is not this, even though you know, we prone to thinking, okay, if I put in the calculator, that is the answer. Unfortunately, that is not the case here. So we're now going to spend some time learning how to reduce roots. Is that something that you've heard or seen before?
Maybe, and I just don't remember, but
So this would have come up in geometry. It might have come up in your Algebra 1 class. Depends on how it's taught. So I'm going to show you how the final answer becomes this. So we're going to learn how to take the square root of 20 to become this over here on the right. Because this is what your teacher expects you to do. And this is what is needed for this trigonometry section. You have to know how to reduce these roots. Okay, so before we can do that, much like many things in math, we kind of got to go back and make sure you are comfortable with remembering what are the prime numbers. So the first prime number is 2, then 3, then 5, then 7, 11, 13, 17, 19, and so on. Could you tell me what, why these are prime numbers or what makes them prime numbers in math?
Now.
Okay.
And
Keep going, sorry.
yeah, no.
Do you don't remember anything about prime numbers? Just give me any fact. I'll take anything at this point.
And I remember having to use them, but I don't know. I mean, I guess one thing I could say is that it doesn't really look like they can. Well, they're other than 2, looks like the rest are all odd. I mean,
Okay, good. I like to. That's something. That's a starting point. And 2 is the only prime number, the only one. All the rest of them are odd. That's important. The definition of a prime number, and what you see here is that it is only divisible by 1, the number 1, and itself. So sometimes it's easier to look at a number that is not a prime number. Okay, and let me just give you an easy one like 20. What number goes into 20 besides 1? What can you divide 20 by evenly?
to 10.
10. Like 20 divided by 10 is 2. Okay. It's also divisible by 5. It's also divisible by 4. It's also divisible by 2. Okay. So that's you know, and okay, when that you're like, hey, well, that's it's an even number. It's like, yeah, but well, it also applies to odd numbers. Like here's 15. What can you divide 15 by?
5.
By 5. Yeah. So that's the thing about prime numbers is they're only divisible by 1 and itself. Okay. The other thing, and I know math is, maybe because math's been a struggle, you haven't sort of found any sort of like anything interesting about it, but this is kind of an interesting thing, I think, is that every number or all numbers are made up of prime numbers. Every number is made up of prime numbers. Now you're in the music world. Remember you said you play the guitar, I think. Is that right?
Yeah.
I don't know very much about music, but I'm sure that there's something to do with music where like there's songs that are made up of just this, or different things that you might play that are only made up of certain things. And that's what's going on here. All numbers are made up of prime numbers. You can give me any number you want, and they're made up of prime numbers. Now, have you ever been, and this just, again, just kind of just help learn a little bit more about you, but you ever paid for something with like a debit card at this point in your life?
Yeah.
Okay, so when you go to the debit card and you insert it, okay, and we still sometimes have to enter our PIN, right?
Yep.
This is called a public key. I'm sorry, take that back. Your PIN is called a private key. Okay. And that credit card or debit card links up with the merchant over here somewhere. And this thing up here is called a public key. Okay, and that public key is an extremely large number that can be very quickly broken down into its prime numbers. But it's huge. It's like billions of numbers, 32 bits, which is pretty big. And this prime number, because everything can be broken up into that, they develop algorithms based on this. So every time you use your card, you don't see this, you just enter your PIN, get your thing, whatever, but there's a lot that's going on here. And it all goes back to prime numbers. They're really kind of useful, very useful, right? Now, I'm not going to say that like the stuff you're doing right now is super, super useful, but you got to learn it for this class. So we're going to use prime numbers, this list of prime numbers, to reduce these types of square roots. Okay. Here we go. Square root of 20. You always start with the smallest prime number, which is 2. Is 20 divisible by 2?
Yes.
2 times what number gets you to 20?
10.
And hey, if it worked, whenever something in life works, you just try it again. Does 2 go into 10?
Yeah.
Okay. 2 times what number gets you back to 10?
5.
Very good. Now this is called a factor tree.
Yeah.
If you don't like it, or you don't see it, if you turn it upside down, I think it looks more like a tree. The outer edges, if you make the analogy to a tree, these would be considered the leaves. The leaves, they're always prime numbers. So that's how you know when you're done. Okay, you're done when there's prime numbers on all the outer edges. We couldn't stop at 10 because 10 is not a prime number. Okay, here's what you're looking for. You're looking for pairs on the leaves. Do you see any pairs?
Yep.
2 and 2. For every pair, you can bring one out.
Then you keep the 5 under.
Exactly. Said perfectly. So the algorithm to do this is fairly simple. You do a prime factorization, you get all prime numbers in the leaves, and then you look for duplicates to bring out. Okay, and that's how we came up with, all the way back here, 2 square root 5. Okay. So if you feel like, well, let's do a couple more here. I want to just throw you into the deep end there on that one. Let's go square root of 28. Okay, so you always start with 2. Does 2 go into 28?
Yep.
2 times what number?
14.
14. And since 2 worked, try it again.
2 and 7. And
Good.
yeah.
We're done. 7 is a prime number. Are there any pairs?
Yeah, it's gonna be 2 square root 7 or whatever.
Good. So here, try these 2 for me, please. And just give me the final answer here, whenever you got them.
Get 2 square root 3 on the first one, and see. And final one, I got 2 square root 11.
Very good. Okay, now a few more examples here, because they're not all like this. Let's try the square root of 45. Okay, smallest prime number is 2. Does 2 work in 45?
No.
So if you're not sure, right, you go to your calculator, 45 divided by 2, and you just get really fast. Boom. Does it work or not? It does not work. What's the next prime number after 2?
3.
Does 3 work?
Maybe.
Grab your calculator and tell me if 45 is divisible by 3.
Uh, 15.
Okay. Since it worked, try it again.
5.
Okay. Are there any pairs?
Yeah, 3.
So your final answer is 3 square root 5. Okay. Go ahead and try, let's have you try this one here. Trying to think of the next one that might be good for you. Let me do something real quick here. All right. Square root of 117. What number should we try first? What's the first prime number to always try?
Well, I don't think it's gonna be 2, so, but
Yeah, but it doesn't work because this is an odd number. So you're
Yeah.
okay if you're like, all right, I'm not gonna try 2. Does 3 work?
let's see. Yeah, 39.
Okay. So try it again. Maybe it'll work again.
13.
Okay. Is 13 a prime number?
D, I'm pretty sure, yeah.
Okay. Again, if you haven't written this list down, I would recommend doing that. I'm happy to, you're going to need this for the problems we're doing today. I'm not going to give you numbers bigger than this. So this would be everything you would need for right now. In fact, you really only need the first like 5 or 6. Do you need a moment to get this down or do you have it?
No, I got it.
Okay. All right. So we left off here 3 times 3 on the outside times 13. What's the final answer for the square root of 117?
3 square root of 17.
Square root 13. Good.
Sorry, 13.
No problem. So here's another one for you to try. I'll throw it right in the middle here. 63. Can you try that for us, please, on your own?
All right. Three can go into it, 21 and 21, 3 and 7. So it'll be 3 square root of 7.
Yes. Okay, very good. All right. So you're doing great. Now we've got to kind of deal with some of the other cases, the other things that could happen here. So let's look at something like this, the square root of 8. We should try 2 first. Does 2 go into 8?
Yeah, 4 times.
Okay,
Or-
and then you try it again. Does 2 go into 4?
Yep, twice.
So are there any pairs?
Yeah.
Okay, so you bring the 2 out, square root of 2. So it is okay. It is okay to have the same number on the outside and the inside. Try this one for me, please, on your own.
Three, third, 3.
I'm sorry, was that your final answer or were you just working through it?
Yeah, that's fine answer.
What's your final answer? Give me one more time.
3 square root of 3.
3 squared 3. Good. Okay, so that's that. We're heading in the right direction here. Here is an exception. Math's full of exceptions. One of the reasons students don't like it, might make me feel like it's frustrating. Square root of 30. Does 2 go into 30? Yeah, 2 times 15. Does 15 go divisible by 2? Nope. So we got to go to the next number, 3.
Yeah,
15.
3 would be there.
Are there any pairs here?
I want to, you can switch it midway through.
What?
Actually,
Yeah. Yes, you can. and
Did
you
you
have
do
to.
that backwards too, though? Like you start, oh, no.
You really want to always start with 2 and then move to 3 and then move to 5.
Yeah, I was just gonna say, cause like, then you could just do 3, then 10, but then you could switch it to 2. 2 times 5 would give you 10, but
Yes. So you do get the same result, but there's an order to it. There's structure. Like pick your analogy in life that, we have rules because it should be better for us in many ways. But this one does not have any pairs, does it?
no.
So you're kind of like, well, what do I do? It's like, you do nothing. Like there's nothing to do. It's just the square root of 30. So sometimes your result is exactly what you started with.
All right.
Here's another possibility. Let's say I give you the square root of 13. What kind of number is 13?
A prime number,
So what's the answer?
13.
Square root of 13 itself. Like sometimes there is no work to do, but you have to, as the math student, have to know, is it like one of these where I start breaking it apart, or is it, nope, there's nothing to do. All right. So let's get back to some ones that actually do work. So you can see some other things here. Let's go with the square root of 72. Does 2 go into 72?
Yeah, probably
Can you
about a lot though.
give me the number there that goes on the right?
36.
Okay. And since 2 work, try it again. Does 2 go into 36?
18 times.
Okay. And hey, worked again. Let's try it again. Does 2 go into 18?
Yeah, 9 times.
All right. And then
3.
3 and 3. So notice you have a pair of 2s and a pair of 3s. So guess what comes out?
No, you know.
Each pair. For each pair, you bring one out. So 2 comes out and a 3 comes out. So for every pair you have, something comes out. Now, what about this 2 that's unused?
Bruh.
It stays in. And the analogy I'll make here is to socks. I like to have my socks be paired up. This analogy falls apart if you don't like to do that. But if I have a pair, I'm going to fold them up. But if I don't, I just leave it in the sock drawer, or wait for another pair. So notice there's a part of the answer that is outside, and there's a part of the answer that is inside. In this problem, there's a 2 on the outside, a 3 on the outside, and a 2 on the inside. When you have more than 2 numbers, 2 or more numbers on the inside or outside, you multiply them together. So this becomes 6 square root 2.
Sorry.
Any feedback on that one? Things you like, didn't like, understand, don't understand?
I mean, now I'm just glad you actually multiplied the 2 numbers, because otherwise it kind of looks stupid, but
Yeah, you want to know what to do. You can't just leave them kind of, hanging out there.
yeah.
Okay, new problem here. Square root of 180. Does 2 go into 180?
Yeah.
Okay. How many times?
90 times.
Good. Does 2 go into 90?
Yep. 45 times.
Okay, I like it. Now, does 2 go into 45?
No. Yeah, switch it.
So we got to go to 3.
Uh, 15 and 3 and 5.
Okay. Do you see any pairs?
Yep. 2 pairs.
Pair of twos, pair of threes. So what goes on the outside?
6,
Okay. Square root of.
5.
Very good. Okay. Now the pairs can actually be the same number. So let's take a look at this. 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. See, there's one pair of twos, another pair of twos. So in this problem, you bring out, sorry, go
4
ahead,
and
4 root 2. Good. All right, let me give you one to try here. Unfortunately, the numbers get a lot bigger. But that is, that there's nothing we can do about that.
yeah.
So give you one here to try on your own, please. Square root of 252. Go ahead and work that out. If you got some questions, please ask.
What is like when we get 2 square root of 2 at the end, what is that called?
This like last little bit.
Yeah.
It doesn't really have a name. It's just the part that does not have a pair, so it's left inside. It's not like a divisor or a dividend or anything like that. It doesn't really have a name. It's the there is kind of this thing. There's the index, and then there's the radicand. If you want to get really formal, it is the radicand. But I mean, unless you got a textbook that's like 100 years old, you're never going to see that ever again. So if you don't mind, try working this one out. Got a couple minutes left here. See if we can get at least this problem done. Maybe one more.
Six square root of 7.
That is correct. Very good. Okay, so here's kind of the whole like coming full circle here. Why do we learn all this? Well, they're going to give you problems where this is going to be 3 and this is going to be 10, and you're going to have to find C. And let me give you a different number. Let's make this 4. And so you're going to say, okay, it's 10 squared plus 4 squared equals C squared. That's 116 equals C squared. And you're going to have to take a square root of both sides. And now you can actually do that. You don't have to do that right now, but that's what that's the whole point of what we've been doing the last 25 minutes.